Second year students, you should have heard this name nama, parallel plate capacitor. Okay, so capacitance of a parallel plate capacitor, parallel plate capacitor. Okay, so first question is this one. First question is why we are using parallel plates. Clear ma? What is the reason that we use parallel plates? Clear? So if you take a single plate also, on this plate also we can store charge, no? Switch on your videos. Okay. See ma? If I take a single plate, on this plate also definitely I can store charge. Then why I have to take parallel plates? What is the reason? For example, if you see any capacitor, capacitors will be of this type. So this is one plate, this is another plate. This is not a straight rod, this is a plate. If I look from this direction, this appears to be like this. Clear? So this is one plate, this is another plate. This forms a parallel plate. Clear? Similarly, if you take what you call cylindrical capacitor, then inside also there will be one cylinder, and surrounding this one, outside this one also there will be one cylinder. Clear? So here also the plates are parallel to each other only, no ma? So inside plate and outside plate, though it is in the form of a cylinder, definitely they are also parallel. Similarly, you can take spherical parallel plate capacitor. So this is one sphere, this is another sphere. Clear? So here also I have two types of plates which are again parallel to each other. Now the question is, definitely we can store charge on a single plate also, no? Why we are using two plates? That is the question. Okay, ma? So answer of this one is this one. We use two plates because due to negative plate, potential on positive plate decreases, and therefore electric field also decreases, so that we can add more amount of charge, onto the plate. We can add more amount of charge onto the plate, and therefore capacitance increases, Clear ma? So this is the purpose of using a parallel plate capacitor. Okay, make a note of this statement, then we will try to understand actually why we are using two parallel plates for a capacitor. Okay ma? On a single body also I can store charge, no ma? But in capacitor always you will find two plates, whether it is a parallel plate capacitor, whether it is a spherical capacitor. And spherical capacitor also plates will be parallel only. Similarly, if you take a cylindrical capacitor, there also plates will be parallel only. What is the reason for this one? We are going to study now. Clear ma? See ma, for example, if I take a single plate, so this is one single plate, I am taking a single plate and I am charging this one. Clear na ma? So if I charge this one, then after some time what will happen? Potential continuously increases, no? As I go on adding charges on this one, potential continuously increases. And what happens to electric field? Electric field also continuously increases. So when electric field reaches to a value of 3 into 10 power 6 volts per meter, now what will happen, ma? Now electric field, because of this plate, when it reaches through 3 into 10 power 6 volts per meter, then what is going to happen? Now further I cannot deposit charges on this one. Clear ma? Even if I deposit charges on this one, these charges will be leaked into the atmosphere, because this is the breakdown electric field of the surroundings, or breakdown electric field of the what you call air. Clear? So beyond this I cannot add charges to this one. Clear? So what I will do is, I will bring one more conductor closer to this one. Clear no ma? So I will bring one more conductor closer to this one, or whether it is a neutral conductor or whether it is a negatively charged conductor, whatever it may be. Clear? So I will draw a diagram here. So this is one plate. so which is positively charged, and it has reached to an electric field of 3 into 10 power 6 volts per meter. Beyond this one, I cannot charge this, because if you add one charge to this one charge will be leaked into the atmosphere. Okay. Now what I do is, near to this one, I will bring one more conductor. So consider this is a neutral conductor. Now can you say what will happen? Can you say what will happen, ma'am? Okay. So to this charged conductor, closer to this one, I am bringing one neutral conductor. Now what will happen? That is our question. What happens now? What happens, sir? Nothing will happen. Huh? What happens is, no, charges will not transfer because they are not connected. No, I am bringing that one closer, that's all. Then what will happen is, clear ba? This total positive charges will be deposited on one side, and this positive charge, what it will do? It will attract a negative charge on the second neutral conductor. So on this side, if negative charge is being attracted, on the other side, positive charge will be deposited. No, this is what is going to happen, no ma? So this is the concept of induction. What is meant by induction? So if you are placing a charged body and an uncharged body close to each other, then charged body will induce charges on even neutral conductor also. So these positive charges, they will attract negative charges on one side, and automatically positive charges will be repelled to other side. Okay. So if this is the arrangement, now what is the effect of this one? Can you say? If this is the arrangement, actually this is a charged conductor, this was a neutral conductor. Now on neutral conductor also charges are induced, but totally it is neutral only, because number of positive charges, negative charges, always they are equal. No? So it is always a neutral conductor, but all negative charges have come to one side, all positive charges have gone to other side. Now can you say what is the effect of this one? Okay, ma? Now I will say, because of this arrangement, potential of charged body decreases. Potential of charged body or charged plate decreases. Okay, ma? So what is the potential of this one? Initially, let its potential be 10 volts. Initially means here let its potential be 10 volts. Now after bringing this plate closer to this one, its potential will become only 8 volts. Can you say what is the reason? Previously, before bringing this uncharged body, its potential was 10 volts. Now after bringing this uncharged body, its potential has become only 8 volts. What is the reason? Reason is very simple. Reason is, here I have negative charges, no ma? These negative charges, they will give some negative potential on the surface of first body, no? This is my first body, this is my second body. These negative charges, they will induce some negative potential on this one. Clear, no ma? For example, let us see how it is possible. So previous potential of this body was how much? Previous potential was 10 volts. Previous it was 10 volts only, no? Previous it was 10 volts. Now because of these positive charges, additionally plus 2 will be added on this plate. Because of these positive charges, potential will increase, no? All of you, are you following, ma? Students, all of you, are you following? So because of positive charges, potential on this plate, will it increase or decrease? Because of positive charges, potential increases, no? So let a rise in potential be 2 volts. Clear, ma? Now because of these negative charges, again potential on this one, will it increase or decrease? Due to positive charges, potential increases. Due to negative charges? Due to negative charges, what will happen? Potential will decrease. Okay, ma? So decrease in potential, is it greater than 2 volts or less than 2 volts? Can you see? Clear, ma? Now decrease in potential is minus 4 volts. So totally how much it is? 12 minus 4 is 8 volts. So capacitance, potential of this conductor has become only 8 volts, no? But here I have same amount of charge. Here also I have same amount of charge. But due to positive charge, rise in potential is only 2 volts. But because of negative charge, decrease in potential is minus 4 volts. What is the reason? So if charges are equal, rise and decrease of potential should be equal, no? But why it is happening? So because of positive charge, rise in potential is only 2 volts. But because of negative charge, fall in potential is minus 4 volts. What is the reason? What is the reason? Potential depends on what? Potential depends on KQ divided by R, no ma? Potential depends on KQ divided by R. Here, Q is a constant, no? So negative charges and number of positive charges, they are equal. K is also a constant. So potential depends on what? Potential depends on distance. Okay. So when compared to positive charges, negative charges is at a lesser distance, no? Are you able to understand, ma? When compared to these positive charges, negative charges are present at lesser distance. So the magnitude of potential because of negative charges will be greater, because when compared to positive, negative charges are at a lesser distance. Okay. So therefore, what is the note point here we have to write? Note point is that the distance of negative charges, the distance of negative charges is lesser when compared to positive charges. When compared to positive charges. Are you able to understand, ma? So therefore, the magnitude of potential because of negative charges is greater when compared to the magnitude of potential due to positive charges. Clear, no, ma? Amount of charge is same. Here also I have minus q. Here also I have plus q. Amount of charge is same. But distance of charges are not same. So definitely rise of potential is only 2 volts, but fall in potential is minus 4 volts. So totally what happens to the potential of this capacitor, ma? Potential of this conductor, what happens? It will decrease. If potential decreases, what happens to E value? If potential decreases, what happens to E value? E value also decreases. If E value decreases when compared to 3 into 10 power 6, it means I can add more amount of charges again, no, ma? Are you able to understand what is happening here? See, ma, potential has decreased. Electric field also decreases. If electric field decreases, now I can add further more charges onto this one, no? I can deposit more charges. If I deposit more charges, then again electric field will rise to 3 into 10 power 6. It means now I got a chance. Now I got a chance to add more number of charges onto the same plate, whose electric field was previously 3 into 10 power 6. But now by placing a neutral conductor, I am able to reduce the potential of this one. If potential decreases, electric field decreases. If electric field decreases, I can deposit more amount of charges. That's all. Logic is very simple. Clear, Nama? Okay. Now I will do one more intelligent thing. Now what I do is, let us see. Ma. Now this is charged plate. So all charges are deposited here. Clear, Nama? So now its potential is how much? Its potential is 8 volts. Clear? Now here I have taken one more plate, no? So this is negative and this totally it is positive. Okay. Now what I do is, this side of this conductor I will ground this one. This side of this conductor I will ground this one. So if I ground this one, can you say what will happen? If I ground this one, then what will happen, ma? What will happen? So this total charge, potential on this side will become 0. It means that total positive charge, it will enter into the ground. This is what will happen, no? Total positive charge will enter into the ground. If total positive charge enters into the ground, then potential due to positive charge, it has vanished, no? Previously, what was the potential due to positive charge? Plus 2. So this plus 2 also has reduced, no? So 8 minus 2 is how much? So now only it is 6 volts. Are you able to understand what is happening? So previously, because of these positive charges, what was the rise in potential? Rise in potential is 2 volts. So that rise of potential will be gone, no? Now what is the total potential of this one? So 10. Now because of this negative charge, decrease in potential is 4 volts. So 10 minus 4 is only 6 volts. Now potential has further reduced, no? Clear, Nama? Potential has further reduced. It means now I can add more amount of charges. So that is the meaning of this one. Okay. All of you, have you understood, ma? So if I ground this one, these positive charges will enter the ground now. Now potential due to these charges, it is gone. Now I have only 10 minus 4, 6 volts. Potential has further reduced, no? If potential has further reduced, electric field also further reduces. If electric field reduces, then what I can say, I can add again more amount of charge. Again it can reach to the potential, it will reach to the voltage electric field of 3 into 10 power 6. Okay. So that is the purpose of placing a positive, another plate closer to this charged conductor. The reason is very simple. If I place one more plate and ground this one, potential of this charged conductor will decrease, so that I can add more amount of charge. Okay, ma? Now you can leave this class and you can enter into chemistry class. Okay, ma? So in the last class, we were studying about capacitance, no? Okay, let us see from there. So, capacitance of spherical conductor. Capacitance of spherical conductor, what we have calculated was C is equals to 4 pi E naught into R. This is what we have studied in the last class, no? So C is equals to 4 pi E naught into R, or we can write capacitance is directly proportional to radius of the spherical conductor. So if radius increases, definitely you can say capacitance of the spherical conductor also increases. Okay, ma? Similarly, we have studied what is the importance of a parallel plate capacitor also. What is the importance of a parallel plate capacitor? So if I place two plates in parallel, then potential on one plate decreases because of oppositely charged second plate. So that is the reason why we are placing two plates such that total capacitance of this capacitor increases. How capacitance increases? So if potential decreases, electric field also decreases. So if electric field has not reached the breakdown strength of air, then definitely we can add more charges. Clear, Nama? So because if you are able to add more charges, it means capacitance also has increased. So in this method, we can increase capacitance of a capacitor by using parallel plates. Clear, ma? See, for example, if I take this one conductor and consider this is another conductor. Clear, ma? So both of these conductors, if I connect by a battery, then can you say what will happen? These two conductors, if I connect them by a battery, then can you say what will happen? Can you say my anybody? What will happen? So if two conductors, these are conductors, ma. Come on, try to say. These are conductors. This is first conductor. Between them? Between them potential difference is generated. So battery is a source of potential difference. Clear, no? So this side of the conductor, it is connected to positive terminal of the battery, no? This side of the conductor, it is connected to negative terminal of the battery. Clear, no? So if positive terminal is connected, then it will attract electrons from this conductor, no? So electrons will start drifting in this direction. So this is the direction of electron flow. So these electrons, they go and they get deposited on this second conductor. This is conductor number 1 and this is conductor number 2. So electrons start drifting from first conductor to second conductor. Clear, ma? So this conductor, is it losing electrons or is it gaining electrons? It is losing electrons, no? So if a body loses electrons, then what kind of charge it will get? If a body loses electron, it will get a positive charge. That's all, Nama. So therefore, this body will become a positively charged body. Clear, Nama? And these electrons, they are continuously deposited on this second conductor. So this body will become a negatively charged body. Are you able to understand, ma? So until the potential difference between these two capacitors equal to the potential difference of this battery, continuously charges will travel from this side to this side. So this is called as a charging of a capacitor. What we call this process, ma? This process we call it as charging of a capacitor. Are you able to understand? So therefore, how can I write a relation between them? Again, I can write same relation. I can write C is equals to Q divided by V. Now, can you say what is C, what is Q, and what is V here? C means what? Q means what? V means what? C means what? C is capacitance of this combination. Clear, ma? Q is what? Q means? Q means charge. Which charge? Charge transferred from one plate to another plate. Clear, ma? So here Q doesn't represent a charge on this one plus a charge on this one. Charge on the first plate plus a charge on second plate, both of them, they will become zero. Why? Because this is the positive charge and this is the equal magnitude of negative charge. Both of them, they will get cancelled. So Q is not total charge. What is Q here? Q is charge on one plate. Charge on one plate or one conductor. Or also you can call it as charge transferred. Charge transferred. Clear, ma? And can you say what is V here? V means what? V means what? V is the rise in potential between the plates. Rise in potential between the plates, potential between the conductors or plates. Clear, ma? Why I am saying this is a rise in potential? How can I say this one is a rise in potential? Because initially while supplying, before connecting battery to this one, potential difference between them was 0. Potential difference between them was 0. After connecting the battery, what happened? Positive charges started depositing on this one, negative charges have started depositing on the second conductor. So therefore, is there any electric field developed between these two plates or not? If charges get deposited, is there any existence of electric field in between these two conductors, or there is no electric field? Can you say? There is definitely electric field. Now, what is the direction of electric field? This is the direction of electric field. That's all, Nama. So this is the direction of electric field. So if electric field is existing, it means the potential is also existing, no? If electric field is existing, it means definitely potential is also existing. Are you able to understand, ma? So previously potential was 0 before connecting this battery. After connecting the battery, potential is V here. Are you able to understand? So therefore V is nothing but the rise in potential between these two conductors after we have connected this battery. Clear, ma? Come on, make a note up to here. Completed? So here, what is Q value that you should understand clearly, ma? Q is charge transferred from one plate to another plate. Q means you should never take this Q and this Q, total 2Q you should not take. Or if you take plus Q and minus Q, total 0, that is not the meaning of Q here. Q is the amount of charge transferred from one side to another side. Okay? Or I can also call Q is the amount of charge supplied by battery, okay, to one of the plates. So like this also we can define charge. Clear? Now, we will study about parallel plate capacitor. All our plates are parallel plates only, but the plates which are parallel to each other and which are plane also, such plates we call them as parallel plate capacitor. So, parallel plate capacitor. Are you able to understand, ma? Now let us see. Clear? So this is one plate, okay? So, which is positively charged, and there is another plate which is negatively charged. Are you able to understand, ma? So if these two plates, if I look from this direction, then they will appear like this, no, ma? They will appear like straight rods if I look these plates from this direction. Okay? So these are two parallel plates whose area of the plates is A. Area of the plates is A. Clear, ma? And the charge present on each plate is Q. So this is plus Q and this is minus Q. So these two plates I am placing them side by side. Clear? Then this is the positive charge which is present here, and this is the negative charge which is present on the second plate. Clear, ma? So first of all, one important point which you should understand is that when you are placing two parallel plate capacitors very near to each other, then charge will be deposited only on the inside surface of these capacitors or inside surface of these plates. What is the reason? Because positive charge is being attracted by negative charge, no? Clear, number? So definitely charges will reside only on inside surface of these capacitors. Make a note of this point. So what is the note point here we have to write? So in a capacitor, charge resides only on the inner surface of the plates. Okay, ma? So this is one important property of capacitors. Okay. Now can you say what is the amount of electric field present in between these plates? So electric field in between the plates. Electric field in between the plates. Can you say how much it will be, ma? So already while studying Gauss law, while studying Coulomb's law, we have studied this one already. So if these are the two plates, then what is the electric field existing between them? Can you say? Electric field existing between the plates is how much? Okay. So what is the electric field because of one plate? Electric field because of one plate is E is equals to sigma divided by 2 E naught. Clear, Nama? And it will be in this direction because electric field will be always away from the positively charged plate, no? Electric lines of force will be always away from the positively charged body. Then what is the magnitude of electric field because of negative plate? Because of negative plate also, electric field will be in the same direction, and it is again equal to E is equals to sigma divided by 2 E naught. Clear, Nama? Already we have studied these equations previously. So E is equals to sigma by 2 E naught due to positive plate, E is equals to sigma by 2 E naught due to negative plate. And both the electric fields are in the same direction, no? Then what is the total amount of electric field? Total amount of electric field is equals to, this is E1, this is E2. So E is equals to E1 plus E2. So therefore I can write sigma by 2 E naught plus sigma by 2 E naught is equals to sigma by E naught. Clear, ma? So this is the amount of electric field which is present in between the plates. Clear? Now area of the plates already we have calculated. Similarly, let distance between the plates. Distance between the plates, let it be D. Are you able to understand? Therefore, can I write a relation E is equals to V divided by D, ma? I can write this relation, no? So already we have studied that electric potential is electric potential divided by distance between two plates is nothing but electric field. Okay? Are you able to understand, ma? Our electric field is also defined as the potential gradient. Potential gradient means what? How potential is changing with respect to distance. That is called as electric field, no? So instead of writing in differential form, just I can write like this also, if electric field is a constant. So therefore E is equals to V by D. Therefore what is V value? V is equals to E into D. So therefore potential is how much? V is equals to sigma by E naught multiplied by D. Why I am calculating V value here? Because I can calculate capacitance. And what is the equation of capacitance? C is equals to Q divided by V. So Q divided by V value is how much? V value is sigma by E naught into D. Clear, ma? Then what is meant by sigma? Sigma is a surface charge density, no? Charge per unit area is called as sigma, surface charge density. So therefore C is equals to Q divided by, instead of sigma I can write Q by A into E naught multiplied by D. So Q and Q gets cancelled, A into E naught goes to the numerator. So C is equals to E naught A divided by D. Clear, ma? So therefore C is equals to E naught A divided by D. So this will be the equation of capacitance for parallel plate capacitors. Okay. So A, what is A? A is the area of the plates, D is the distance between the plates. Okay. So by looking at this equation, what I can understand that if area of the plates increases, capacitance increases. Similarly, if the distance between the plates decreases, then also capacitance will increase. Okay. Come on, make a note up to here.